Alright guys, today we're gonna learn decimal subtraction. The only difference between whole numbers and decimal subtraction is just decimal. Well, let's do it. Suppose we have, oh hell no. For example, easy one, 39 minus 2. That'll be easy. You can just solve in your brain and it's gonna become 37. So now we're going to go 3-digit. Now you can still solve in your brain. I'm not saying you can't, but it'll be a bit difficult for you to do that. So now we're going to line the numbers up and then draw a line. We have the subtraction here. Actually, we're gonna do addition first. Oh my god, what is okay. Let me just line them up manually. What is this? Okay, there. Chill, cool off. Like cool down, chill down, or chill off. Alright, so suppose we have this problem here. And then we're trying to solve it. We line the last digit up if it's an integer. No, not integer, whole number. And then we start from the rightmost side. 4 minus 1, 4 take away 1 is 3, no doubt. 0 take away 3, we cannot take away 3 from 0. You cannot get negative numbers in a whole number. In a whole number subtraction that is bottom number smaller than the top number. So we gotta borrow. Now 3 is gone. 3 is not 3. 3 is a 2. 0 is not 0. 0 is a 10. 10 minus 3 is a 7. So we got 73. Alright, that was kind of cool. Now we're actually stepping in the world of decimal. Decimal, if you think of like this, it has no difference. Decimals are literally just whole numbers, and then decimal whole numbers. You can just think like that. That will reduce your stress of like so hard. It's part of a whole. I mean, it's not wrong, but still, don't think of it that hard. Decimal subtractions are not that hard. So suppose we have 300.1. That was, and then minus 293. We're gonna start with a friendly one. We gotta gather the two numbers, line them up. Notice that we don't line up the last digit because now we line up the decimal. When we look at those sheets here, what we just did here, it makes sense because that there's an invisible decimal at each end of a whole number. So it makes sense. Now, come back. If you don't want to leave this part blank or you want a better view, you can just turn this into a 0 since there's nothing behind the decimal. Alright, draw a line that was squeaky. And then 1 take away 0 is 1. 0 take away 3. You cannot do that. You cannot do that. You have to borrow. 0. I can borrow nothing from 0. And then this 0 asks its neighbor, can I have a 10? 3 says yes. 3 became a 2. 0 became a 10. And then this 0 is like, give me my 10. I asked you for a 10. You asked the other people for a 10. Now you have to give me a 10. So this 10 becomes a 9. This 10 becomes a 10. This 0 becomes a 10. Now we can actually do it. 10 take away 3 is 7. Notice that we line up the decimals everywhere. Everywhere. Literally everywhere. Line up the decimals. Or else your answer is cooked. Okay? Alright. 9 take away 9. Okay, 0. Nice. 2 take away 2, 0. We don't need the 2 zeros at the front, so it's 7.1. 7 and 1/10. Alright, that was interesting. If not, just review some more, sort out those problems. And now we're actually getting to the real decimal part. Decimals just basically whole numbers, point whole numbers, like I just said. Decimals not that complex if you think of it that way. So for example, we have 203.5 and 101 point. Let's do a one that do not require borrowing. And then we line them up. And then we draw a line. We put the minus sign on the left. Then we start calculating. The decimal always in the same spot, where it lines up everywhere. Lines up. It has to line up. Okay, it has to line up. No questions. You have to line up. 5 take away 4 is 1. 3 take away 1 is 2. 0 take away 0, obviously 0. 2 take away 1 is 1. So the result is 102 and 1/10. However, there might be times where you see things like not this friendly. That's called, there's this awkward thing in subtraction called borrowing. As we just said, this freaking digit literally asks its neighbor for a 10. That's just, oh my god. So imagine you have 132.5 again, and then let's do a 2-digit, friendlier. 30. Yay, multi-borrowing. 33.6. Alright, let's go. Put the minus sign. The left. Alright, let's see here. 5 take away 6. It's impossible. Okay, it's impossible. So we have 6/10 here. And then we want 6/10 from 5/10. The 5/10 cannot give 6/10. So it asks its neighbor right here. Yeah, that's 1. You did not hear wrong. Because 10/10 is actually 1. Not if that makes sense. 10/10 is actually 1. So 1 whole. Cause look, 1/10 is just 1/10. And then 1 times 10. You can just add it. 1 times 10 added 10 times. It's gonna become 10/10, which is 1 whole. Alright. That's it's good. I don't know, but still Let's continue. We asked the neighbor, hey, Mr. 2, can I have 10/10? He's very generous. He says yes. And then the 2 turns into a 1. The 5 turns into a 15. Now 15 take away 6. That's now good. That's all good now. We have 9. And then 1. The 2 is like, oh my, I shouldn't have give it out. Now I have to borrow. He asks his neighbor, which is a 3, so nicely, actually begged him. So the 3 gave him a 10. 3 became a 2. 1 became an 11. 11 minus 3, 8. 2. Oh my god, I have to borrow again. Okay, this guy's gonna sacrifice himself. Now it becomes a 12. 12 minus 3 is 9. So the final result is 98.9. Again, line up the decimals. Way too important. Alright. Well. All good. Alright. Now we're gonna do a last round of demonstration. What the hell is this? I just want to make the eraser sicker. What's the problem? Alright. Get that out. Alright. Now we're going to do another problem, but where it's like the digits behind the decimal point is not lined up. It's not lined up. For example, 302. Am I saying how he's so friendly? Nope. 1 0. Let's keep it simple. 101.3. Oh, come on. How are we supposed to do this? Well, that's why I'm here. Well, that's why I'm here. What do you think? Alright. So, whenever we have nothing behind the decimal, we should know that adding or removing a 0 at the very end of each number, not in the whole numbers part, but in the decimal part, adding or removing the zeros at the end does not change its value. Be careful. This only applies to the ones that to the numbers that are behind the decimal point. What is this zoom? That only applies to the ones behind the decimal points. So if we add a 0 here, 302 is still 302. Behind the decimal, okay, behind the decimal. Alright. When we know that, we can add a 0 to the end. This helps us a bit. Now, we're gonna look at the 0. Oh no, 0 can't give 3. It's gonna ask its neighbor, hey 2, can I have a 10/10, please? She's like, okay, sure, why not? And then the 0 becomes a 10. And then 10 can finally pay the tax. He can finally give 3/10 out. So he remains in 7/10. Line up the decimals. The 2 has been nice, given out 1, so it remains 1. Now, what are we gonna do here? How to take 1 out of 1? Well, 1 minus 1 is 1. No. You really trust that? That's crazy. 1 minus 1 is 0. So it just asks you, can I have one? He's like, okay, I'll sacrifice yourself anyways. 0 minus 0. Well, no tax day. Yay. 3 minus 1. He want 100. Should we give it? Yeah, sure, why not? We're being generous. Alright, so this results in the number 207 tenths. So this is how we do decimal subtractions. If you like this video, subscribe, like this video, and then comment. Hope you have a nice rest of the day. Alright, subscribe, and bye.